Hey folks, welcome back for part 2 of the 4020 in-frame overhaul that started off as a head gasket. Not this 4020, this one's getting a clutch. Different 4020. We'll get to that one. I don't know if I was clear in the last video of why I was actually overhauling that engine, just because of the head gasket, or what was the deal. I don't know if I made that clear or not. The reason why it turned into an overhaul was simply because those liners were leaking through the weep holes. When that happens, most of the time the O-rings are rotted out, which means the liners are also going to be rotted on the outside. And that's what happened on this one. When we pulled those liners out, you can see here very clearly how they're really rusted and pitted. And if I would put these back in, it would only be so and so long before this tractor would wind up having coolant running back into the combustion chamber, and now it's going to be burning coolant. So the right thing to do is just make it all new again like it was supposed to be in the first place. The tractor was bought with a rebuilt engine. It was supposed to be rebuilt, but it wasn't. That engine had a lot of hours on it, a lot of time. Some stuff was done, some stuff wasn't. We'll get into more of that. Anyway, I wanted to explain that a little bit. At this point, let's just get right on into the video. All right, those are all tight. Crawled underneath there and checked to make sure I didn't have any O-ring protruding anywhere, and I make sure I didn't shear them off. Looks all good, so now I'm going to throw my top rings in and we'll see what the gap is like. Okay, so first things first, the liners are installed and they're being held in there with the bolts. Then I drop in my top rings, and those rings have to be square to check the adjustments, or to check the ring gaps. So that tool that you see there is an adjustable tool with the same length of machined legs, and I drop those down on top of the ring and push them down so that the ring gets down about an inch, inch and a half inside the bore, right to where the bore should be nice and square. You don't want to be checking this right at the top or right at the bottom or anything like that. Next thing, I'm here with the feeler gauges, and what I'm doing is trying different sizes, sticking the feeler gauge in the gap and seeing what fits. Note this one's too big, I'll add another couple thou. You do your math and you just use 2 feeler gauges side by side, or 3, or whatever it takes, sandwiched together to get the right gaps. And then I run away and I record that, and then I come back and I do the next cylinder. And that's how you check the ring gap on these. The ring needs to be square in the bore, it needs to be set down far enough that you're not measuring near the top, and then you just use a feeler gauge and match up different thicknesses until you get exactly the size that fits into that gap. You do that for the top ring, and then you do that for the bottom ring, and you do that for your oil control ring all the way through. Okay, I just finished checking the ring gap on the top ring on all these cylinders, and these rings came off the pistons that came in each one of these sleeves. Remember, they were assembled and I disassembled them, even though I'm not supposed to do that. You know, a lot of people believe that when these piston packs are assembled that way, that the ring gap has already been adjusted to the sleeve. Well, if this is adjusted to the sleeve, then it's pretty sloppy. Take a look at that there. We got number 6 is 16 thou. Number 4 is 26 thou. So the minimum spec is 13 thou on this tractor. I don't have a maximum spec, I just have a minimum spec. It's 13 thou. So number 6 is 3 thou off from minimum, and number 26 is double what minimum is. So that's a pretty big difference. So to put that in perspective, here's 13 thou beside 26 thou. That's a big difference, and you might not think that it looks like that much. And I mean, really, it's only 10 thou, you know, it's not that much. But remember, you got 300 plus PSI compression in that cylinder, and that ring is the only thing that seals that air from getting down into the crankcase. And that little gap right there, that's all you get to seal it. So the average Joe would never be able to tell any difference in the way that engine operates just from that. And that's not what I'm saying. It's just, like I always say, there's just something to be said about a finely tuned machine. You're in here doing all this work, I don't know. I just like to go through and make this stuff all as perfect as I can. I know it doesn't wear at the same rates and it doesn't wear as the same amount, but why wouldn't you at least start with it right, you know? There! An hour of ring filing and checking and everything else, and we got them all set now. I'll show you where we're at. So that's what we wound up with there. That's how uneven the ring gap was, which the engine would have run just fine, but we can do it better if you're more of a numbers person. The numbers are just all over the place. Not that huge of a tolerance, like 10 thou 3 thou on the intermediate and 5 thou on the oil control. Actually, that intermediate was pretty consistent. That was pretty good. The oil control wasn't that bad either, but anyway, now when I'm finished, my gaps are all the same all the way across. Your second ring is more of a scraper than a sealing ring, so that's why it always has a little bit higher ring gap. The top ring or combustion ring, that one is the one that's your main sealing ring, and they always told me that on your oil control, whatever comes past your top ring is going to go out the bottom, so you never want your oil control to be smaller than what your top ring is. So according to that, these rings are set up perfectly now. That means I can take and put the rods on the pistons, and then I can put the rings back on the pistons, and then I can drop them in there. But I'm going to call it for today, folks. We're having company tonight, and I am expected to be there. Alright, I just finished putting all the rods on these pistons. I really like this on these rods. They're actually labeled front on all of them. And then, of course, your piston also is labeled front. It's kind of hard to see in the camera there, but so it's real easy to know which way the rods go, because that angle matters when that goes in the crank. So you want to pay attention to that when you're putting these engines together. But this one's really nice. They're not all labeled like that, so that's pretty sweet. Anyway, so I threw the rods on. That's good. Now I'm going to start throwing the pistons in, but first I got to put the rings back on. I'm going to do that, get them all oriented correctly, and I'm going to be starting with number 3 and number 4 cylinders, because it is easiest to load these pistons in there when your rod throw is down at the bottom. Like that one is at the bottom, that one's halfway up, that one's kind of just past top. So that is number 3 and number 4. Those are the two that are at the bottom right now, so I'm just going to start with them. You never want to be in a hurry putting rings on. It's a delicate procedure. You don't want to expand those things any farther than you absolutely have to get it over top. So if you're careful and you take your time, no problem. So you want to put lots of oil on our pistons. We can get all in the rings and keep everything lubed up nice as it goes together. And of course you want to do the same in your cylinder. Lots of oil on the cylinder walls so that when your piston goes down it's not dry. Okay, and then we're going to throw our ring compressor on the piston, which I've done. And this is number 4, so it goes in number 4 hole. Front faces the front. Oh, I'm pinching my finger. Okay, just gotta grab a hammer. You didn't think I was gonna whack that in there with an actual hammer, did you? Ooh, she's pretty tight, that one. There we go. Hang tight, I'll go get the other one. Okay, number 3, same thing. Make sure the front is facing the front. Whoops, drop them down there. Yeah, and then we're just going to tap it down. The reason I have to tap it down is to push it through the ring compressor. There's a bit of friction on those rings there, so. You don't hit it very hard. Maybe seems like I am, but I'm just kind of tapping it. This is a very small, light hammer. Okay, those two are in. Front is that way. Front is that way, so we're good. I've got my number 3 and number 4 rod caps here. I just finished lubing my rod bolts up with moly paste. Some guys use oil. There's nothing wrong with that. Oil works good too. Most of your repair manuals tell you to use oil. I use the moly paste because it's just a little cleaner. I really don't like that when I'm laying underneath there and I got oil dripping in my face. We're gonna get the bearings ready here. Yeah, nice shiny new bearing. Ooh, pretty. You never want to touch the inside of that with your fingers. The oil on your fingers will actually eat that bearing material. I have done one engine before where I pulled it apart and there were literal fingerprints on those black fingerprints in there. And those bearings were pretty wore too. So those fingerprints etched in there a long ways. So all I'm doing here is just putting the bearing shells in. Oh, it's already open. And once I got them ready there, I'll just grease them up. Again, I'm using driven assembly grease here. A lot of guys use oil. Oil's fine, there's nothing wrong with that. It works just fine. But again, I just find that with the grease in here, I don't get drips in my face working underneath here quite as much. It's just a little bit cleaner. Just personal preference. Okay, let me grab my creeper and then we gotta crawl under the tractor. Alright, so under here, oh, I gotta give this a little wipe. Just want to make really sure that these bearing surfaces are all as perfectly clean as they can be. Okay, so first thing I'm going to do is I'm going to grab my rod up here and just pull the piston down a little further. Just a little more yet. Okay, then I'm going to put my bearing on. Nothing too crazy here, it just clips in just like it does on the lower side. Make really sure that your oil hole lines up, because that wrist pin is oiled through the rod. Let's see if I can pull this down. There we go. Probably would make sense to put a rod cap on there now. Look at that, eh? I'm gonna have to turn this motor a little bit more. Hopefully I turned it the right way. You have to turn it a bit more. Okay, that's better. Now same thing for this one. Okay, and then of course it is imperative that these get torqued properly to the right spec, so I'm going to use my DeWalt torque wrench for that. Torqued. Yeah, I was just kidding. Book says 130 pounds of feet on these, so I'm going to torque these to about as much as I weigh. Gonna get myself in a good position. You're really in the way over there. What do we got here? 130.3. That was pretty close. Huh, 130.2. Okay. There we go. Okay. Okay, those two are done. I'm going to go ahead and roll this over until the next two throws are at about that same angle over here. So you just watch this for me, and when it gets there, just yell, and then I'll know when to stop. How are we doing? Are we getting close? Okay. How about now? A little more? How much more? Okay, good, thank you. Oh yeah, that's perfect. Awesome. Thank you. Okay, so you got a pretty good idea what I'm doing here. Now let me get the rest of these pistons dropped in here, and then after that I'll get back on the camera, because to be honest, you're really in the way underneath there. So I'm just gonna get this done, and then we'll keep going. I bought new rod bolts. I don't like reusing rod bolts. It's just a thing. You're supposed to be able to reuse these if they're not stretched too far, but I always buy new ones. Well, not always, but most of the time. So we want to make real sure that our ring gaps are set in the right spots. I like to do it just like the John Deere book showed there. Wrist pin is here. I like my oil ring gap about there. That means the top ring is going to be on that corner, and the middle ring is going to be on that corner. So we are exactly staggered like that, like that, like that. That's how I do it. When lining up your piston ring end gaps, I always say not to align the gaps with the wrist pin. There's science involved, and I can't properly explain all that stuff, but one of the reasons is one that a lot of guys, even a lot of mechanics, don't know, and that is that pistons are not round. They're actually not round. If we take our caliper here and we measure the skirt in line with the wrist pin bosses, we get about 4.235. Now, if I just run this around, you can see it growing as we get in line with the thrust surfaces of the skirt, and now it's about 4.242. So this piston is, what is that? We're 1/7 thou out of round. Thicker at the thrust surfaces and thinner in line with the wrist pin. There's something to do with that, is why you don't want your ring gaps lining up here. Another thing is checking piston to wall clearance. I've seen guys try to do that from the top of the piston when it's down in the bore, and then they'll take their feeler gauge and try and go in between here. That's really wrong too, because the top of the piston is smaller than the bottom of the piston. So if we measure this, we got 4.21, okay? And if you remember what the other side was, I don't. 4.24. So we got 30 thou difference between the skirt and the crown of the piston. So you always want to be checking your piston to wall clearance from the bottom side, and also from the thrust sides of the piston, because that's where the piston is bigger. Here's another piston I've got from a different motor. So where the wrist pins, that surface measures 3.37, and the thrust surfaces 3.38. So we've got a difference there, and this is a worn piston. So those thrust surfaces should actually be a little bit more than that, but that's a used piston out of an engine that's getting rebuilt because it was wore out. You'll also notice the piston is marked front, and the reason why that is because the wrist pin is not in the center of the piston. I don't have an effective way to measure that and show you on camera, but the wrist pin is often offset on your piston, and that has to do with the angle of the rod on the crank. There's a lot of geometry that goes into pistons, wrist pins, crankshafts, rods, all that stuff. There's a lot of geometry in there. It gets pretty complicated. I had an engine in a tractor once that engine just hammered like crazy. It ran fine-ish. Well, it needed injectors and stuff, but I mean, it ran okay for what it was, but there was just a pile of diesel knock, and I couldn't figure out what was going on. And then due to some other circumstances in the situation, I wound up pulling the head off, and yeah, the engine had been rebuilt, and 3 pistons were in backwards and 3 pistons were in the right way. So 3 of them were facing the front and 3 of them were facing the back. It is important which way your piston goes in that cylinder. Woo! Look at all those fancy high-performance pistons in there. Woo-wee! Nice. Well, those are all in. Everything's torqued up in the bottom. So now I gotta clean the bottom of the oil pan, I guess. What I mean is I didn't clean this gasket surface yet. I should have done that already, but I didn't. Didn't feel like laying underneath here and doing that, but now I have to, because the next step is to put the oil pump in. And I don't want that thing hanging here in the way while I'm trying to work around here. So I guess I'll do that, clean that up, get the oil pump in, and then I can get the head ready to drop it on. Well, that's going to do it for this video, guys. Don't forget to subscribe so you don't miss out on part 3 when that comes out, where we throw the head on and go through all the processes involved in doing that. Thank you so much for watching.